Hi friends. So let us see one more problem, that is exponential signals are orthogonal or not. So in the previous problem we have seen whether the sine omega naught t, sine and cos signals are orthogonal or not. So in this video we have to verify whether the exponential signals are orthogonal or not. Here the given exponential signals are what? 1 comma e power plus or minus j omega naught t comma e power plus or minus 2j omega naught t comma e power plus or minus 3j omega naught t and so on are orthogonal or not. So we have to verify. So we have to take for complex type of signals. So this is the formula for complex exponential signals. So for normal orthogonality, if you verify orthogonality of two signals, we have to no need of conjugate here. So if in case of exponential type of signals, we have to put conjugate, that is xm of t into xn conjugate of t dt is equal to 0. Here m is nothing but the first signal, n is nothing but second signal. That is nothing but if you write x1 of t into x2 of t conjugate of t dt is equal to 0. So that is also no problem. So this is a one is conjugate value. That means, so if you write this one, it is equal to 0. When it is equal to 0, here both m and n are not equal. If m and n are equal means we are getting some value, that is we are taking here as en. So first we have to take xm of t signal. Here xm of t signal is what? E power jm omega naught t. And xn of t signal is what? E power jn omega naught t. Then substitute these values in this equation, that is e power jm omega naught t into e power jn omega naught t conjugate into dt. So conjugate is nothing but what? If we apply a conjugate to the exponential signal, we are getting minus. If here is minus, if we apply conjugate means we are getting plus. So e power jm omega naught t into e power minus jn omega naught t. So it is in the form of a power m into a power n. So you have to write e power j is common, m minus n omega naught t into dt. So now integrate this value. So if you integrate this value, we are getting e power of j into m minus n omega naught t divided by j into m minus m omega naught with limits t naught to t plus t naught. So we have to take the limits as t is in between t to t plus t naught, or we have to take t is in between t naught to 2 pi by omega naught. So what is omega naught value? 2 pi f. How to write f? 2 pi by t. Right? Now what is t value here? 2 pi by omega naught. So here t is nothing but this value. So here we are writing 2 pi by omega naught value. Okay. So now you have to write the value of t is in between t to t plus t naught. So here we are taking t plus t naught value. So now after integration, you have to substitute the limits of t. Upper limit is t plus t naught and lower limit is t. So if you substitute the upper limit, then multiply omega naught into t into omega naught into t naught minus e power j m minus m omega naught t. So here in these two, which one is common? E power j m minus m omega naught t is common. Remaining part e power j m minus m minus n omega naught t naught minus 1. So what is omega naught? We already know that one. What is omega naught value? 2 pi by t. So omega naught t naught is equal to what? 2 pi. So in this place you have to substitute, in place of omega naught t naught you have to substitute the value 2 pi. So that is nothing but e power j m minus m 2 pi is equal to 1. Here the value is what? 1. So that means this value is 1. Then 1 minus 1 is equal to what? 0. Hence the complex exponential signals are orthogonal to each other. Thank you. So this problem is very important for exam point of view, J into H or J into K also. Thank you.